Hello everyone, this is Miss Chelsea and today we'll be discussing hydrates. Our question of the day is what are the properties of salts or compounds with ionic bonds? Current standard is SC3C, which is to use mathematics and computational thinking to apply concepts of the mole and Avogadro's number to conceptualize and calculate percent composition, empirical molecular formulas, the relationship between mass, moles, and molecules, as well as molar volumes of gases. What are hydrates? Well, a hydrate is a crystalline ionic substance that contains a definite amount of water molecules that are physically associated with it, aka trapped inside. Basically, imagine the water molecules as being stuck inside a jail formed by the ions. We can remove this water from its ionic prison by heating the compound up. Because the water is physically associated, it will only take a physical change to get the molecules apart. Once the water has been evaporated, what's left over after the water has been removed is called the anhydrous salt. Anhydrous meaning no water. Using our percent by mass equation, we can actually determine how many grams of water are to be removed from a sample. Once you calculate the percent by mass of water, you can use a ratio to determine exactly how many grams would be lost when heated. This is used to help you calculate percent error when drying a hydrate. Percent error meaning how far off you are from the expected result. Keep in mind, some hydrates actually experience a color change when drying. So if we want more precision, we can calculate how much mass should be lost due to drying the sample. Then we're going to continue drying and taking this mass until you have a constant mass. The mass doesn't change. This ensures that we've totally dried the sample. Let's try an example. What is the percent by mass of water in CuSO4.5H2O? Or copper sulfate pentahydrate, penta meaning 5, hydrate meaning hydrogens are attached. Well, we know there are 5 water molecules physically attached to each unit of the copper 2 sulfate. We're going to start by calculating the formula mass of copper 2 sulfate pentahydrate. When we do this, make sure you keep water's atoms separate from the other elements in order to keep the calculations from getting all mixed together. So, since oxygen shows up in both copper 2 sulfate and water, you're going to have to list oxygen twice. Copper 2 sulfate has 1 copper, 1 sulfur, and 4 oxygens. Water, on the other hand, you will have 10 hydrogens and 5 oxygens because you have a pentahydrate. Pull in our masses from the periodic table, 64 for copper, 32 for sulfur, 16 for oxygen, and 1 for hydrogen. Multiply across each row to get the total mass for each element, 64 for copper, 32 for sulfur, 64 for oxygen in the copper 2 sulfate, 10 for hydrogen, and 80 for the oxygen in the 5 waters. We can then add the masses of our hydrogen and oxygen in water to get 90, and we add everything together to get the formula mass for the copper 2 sulfate pentahydrate. Percent of the hydration is going to be the mass of the water, 90, over the mass of the total, 250, multiplied by 100. So the water, or 90, is the part, and the 250, the total, is the whole. Once we divide that, multiply by 100, we get 36%. We can actually look at an application of this. If 5.2 grams of copper 2 sulfate pentahydrate is heated, what is the expected final mass when the compound is totally dehydrated? Well, from our chart, we know that there are 90 grams of water for every 250 grams of the hydrate. And we want to know how many grams of water would be removed from 5.2 grams of hydrate. So we would put X, the unknown amount of water, over 5.2, the total. We can then solve for X by cross multiplying. 90 times 5.2 is 468. Then on the other side we have 250 times X. We can now solve for X by dividing by 250 on both sides. And we get that X is 1.872 grams. That means of the 5.2 grams, 1.872 of that is water, and the remaining is the copper 2 sulfate. Let's subtract, and we find that there are 3.328 grams of leftover anhydrous salt. Alternatively, we could use the percent. If 5.2 grams of copper 2 sulfate pentahydrate is heated, what is the expected final mass when totally dehydrated? So we know that 36% of the compound is water. So we want to know what is 36% of 5.2, or x equals 0.36 times 5.2. Keep in mind, we always change percents to decimals before performing math with them. Once we do that calculation, we once again get 1.872 grams of water, and then we have to subtract to get the leftover salt. Now, there are some sources of error when dehydrating salts. For example, water can become trapped underneath crystals and therefore have difficulty evaporating. This is why we should always cool the evaporating dish and check the mass, then heat the sample again. If you end up with a constant mass, you can assume you've dried the sample as much as you really can. Don't forget to do a percent error calculation to determine if your results are valid. Percent error is calculated by taking your experimental results, subtracting the accepted answer or your calculated results, and dividing by the accepted results, then multiplying by 100. Results are only valid when the percent error is under 5%. As an aside, let's talk about naming hydrates. We always name the ionic part by following the regular rules for ionic naming. We then use the number of water molecules as the covalent prefix, so mono, di, tri, so on. And it ends with hydrate. So, like we said earlier, copper 2 sulfate is CuSO4, but we called it pentahydrate because there were 5 hydrogens.